There is something chilling about the phrase black hole, which suggests nothingness and incites feelings of danger, and alludes to something that could pull us in and entrap us. A black hole colliding with Earth would be the worst disaster ever imagined. Even if it's improbable, merely thinking about it might teach you a lot. Hundreds of billions of stars have formed in the Milky Way alone, implying that there are hundreds of millions more black holes to be found. Black holes move through space in the same way as stars do, even though they don't emit light. Thus, a stealthy black hole may approach us unobserved. So what if Earth falls into a black hole? Is it possible for the Earth to fall into a black hole? Should we be scared of black holes? Just sit back and watch the video to the end to find out more today. Black holes are some of the most terrible and enigmatic celestial phenomena that exist just beyond our vision. So let's start off with some good news. Even though the universe contains a large number of black holes, including within our galaxy, the chances of one of them colliding with Earth are extremely remote. Approximately 1 out of every 1,000 stars, according to the Space Telescope Science Institute, is large enough to form a black hole. The Milky Way galaxy is thought to have 400 billion stars. And while individual stars are massive, the distances between them are enormous in comparison to not just their sizes, but also the proportions of the stellar systems they anchor. A gloomy atmosphere. Though discovering black holes is challenging, NASA thinks that the Milky Way could include anywhere from 10 million to a billion stellar black holes. The closest black hole to Earth that is known as the Unicorn, and it is about 1,500 light years away. The nickname has two meanings. Not only does the black hole candidate sit in the constellation Monoceros, the Unicorn, but its extremely low mass of roughly 3 times that of the Sun makes it one of the most massive objects in the universe. The issue about early universe processes is that if there is some kind of unusual mechanism that can generate black holes, it won't just manufacture a few of them, it'll flood the universe with them. Indeed, there may be enough primordial black holes strewn about the cosmos to account for at least a chunk of dark matter, the enigmatic substance that makes up over 80% of all matter in the universe. Fortunately, black holes aren't completely black and they lose mass due to Hawking radiation, a complex quantum mechanical mechanism that permits some particles and radiation to escape from the black hole event horizon. They lose mass more quickly as they get smaller. Within the current age of the cosmos, black holes weighing less than 100 million tons, about the same as an asteroid, will lose roughly half of their mass. Black holes larger than that will only lose a small proportion of their mass due to the way Hawking radiation works. The overall number of little black holes in each galaxy is determined by the amount of dark matter you wish to explain and the size of each one. The No Hair Theorem of a black hole. A black hole's mass, spin or angular momentum, and total electrical charge are the 3 qualities that can, in theory, be measured. Indeed, since all other information about anything that goes into making up a black hole is lost, these are the only 3 parameters that an outside observer may ever know about. The No Hair Theorem describes this situation. Simply put, no matter how hairy or complex an item is, it will be reduced or shaved to its mass, charge, and spin and if it is thrown into a black hole. Mass is unquestionably the most important of these factors. A black hole's mass is concentrated in a vanishingly small volume, the singularity, and this is the precise definition of a black hole. Spaghettification. Spaghettification is an innovative name for one of the most well-known effects of a nearby black hole. In a nutshell, if you get too close to a black hole, you'll start to spread out like spaghetti. A gravitational gradient runs through your body, causing this effect. Assume you're walking into a black hole with your feet first. Your feet will experience a larger gravitational pull toward the black hole than your head since they are physically closer to it. Worse, your arms will be drawn in a slightly different vector direction than your head because they are not in the center of your body. Parts of the body towards the margins will be drawn inside as a result of this. The end consequence is a thinning out or compression of the body in the middle, as well as an overall elongation of the body. As a result, your body, or any other object such as the Earth, will begin to resemble spaghetti long before it reaches the black hole's center. The mass of a black hole will determine the precise moment at which these forces become too strong to endure. This could be hundreds of kilometers away from the event horizon. the point beyond which no information can escape a black hole, for an ordinary black hole created by the implosion of a high-mass star. An item might easily plunge below the event horizon before becoming spaghetti at a distance of many tens of thousands of kilometers from a supermassive black hole, such as the one estimated to exist at the heart of our galaxy. So what would happen? What if a black hole the size of an asteroid collided with Earth? To put it plainly, disaster. The black hole would pierce the surface of our planet like a hot knife through butter, but due to its gravitational interaction with Earth, it would immediately begin to slow down. This means that the same gravitational effects that cause spaghettification would begin to affect this situation. Any atom, molecule, or person that came into contact with the event horizon, the black hole's boundary beyond which nothing, not even light, can escape, would just simply vanish from the known universe, never to be seen again. The black hole would exit through the opposite side of our globe in the best case scenario, leaving the survivors to clean up the debris. In the worst case scenario, the black hole would collide with our planet's core where its gravity would be sufficient for it to begin feeding. It would eventually consume the entirety of our world. Thankfully, the chances of a black hole settling in Earth's core, according to calculations and paper, are extremely remote. The speed of black holes is simply incomprehensible. Our planet colliding with a black hole, on the other hand, would result in another unpleasant reality: heating. The black hole would accrete matter as it passed through Earth, generating heat in the process, the same heat that powers active galactic nuclei. An asteroid-mass black hole colliding with a kilometer-wide asteroid would release roughly the same amount of energy. But don't get too worked up. We'd have to be unlucky to strike a black hole in the first place, and even after the crunch, we might be able to live on holographically anyway. Similarly, if a genuinely gigantic black hole swallowed us beyond its event horizon, we might not even notice because everything would appear to be as it was before, at least for a short time. It could take a long time for calamity to strike in this situation. The idea of a planet around a black hole may be alluring. There must be a source of energy or a temperature difference for life to thrive, and that source could be a black hole. However, there is a catch. The black hole must have stopped devouring matter, or it will spew far too much radiation to host life on any nearby worlds. So whatever enters a black hole will eventually be ripped apart into individual atoms, regardless of its size. Anything that crosses it will be affected. It doesn't matter whether it's people, planets, or stars. Our entire solar system would be doomed, unfortunately. The sun and our planet's delicate balance would be disrupted, potentially causing them to collide. To make matters worse, our asteroid belt would be drawn in our direction. There are about 200 asteroids larger than 100 kilometers, 62 miles, in diameter among the 552,894 asteroids that we know of. So we'd be dead before we turned into spaghetti if one hit us. Let us know what you think in the comment section below and give us a thumbs up by hitting the like button. Don't forget to subscribe to our channel and turn on post notifications so you don't miss any updates from us. Finally, go through the channel for more videos like this. Thank you for watching, and we'll see you in the next video.